Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have, this is nice radical equation. A times square root of A is equals to 1, and we solve this problem for all the values of A. So here the very first step we are going to do is, first we need to remove this radical sign, and in order to remove this radical sign we need to take squaring on both of the sides, and this will be written as a times of square root of A and its whole square is equals to 1 square. And now further, in the next step we break the square from left hand side, and we apply the square separately on both of these two values, and we get here a square multiplied by square root of A and its whole square is equals to, this is 1 square, and we know about that 1 square is equals to 1. And further, in the next step we need more simplifications here, and you see that in the left hand side, this is a square is multiplied by this 2, and this square root are gone, and we get a, and this is equals to 1. And now here, a square multiplied by a becomes a cubed is equals to 1. And further, in the next step we move the term 1 from right hand side to the left hand side, and we get a cubed minus 1 is equals to 0. And now we rewrite this equation as a cubed minus, we write this one as 1 cubed, because we know that 1 cubed is equals to 1, so we write this one as in the form of 1 cubed, and this whole equation is equals to 0. And now further, in the next step we use here the nice algebraic formula. So we have x cubed minus y cubed is equals to x minus y times of x square plus xy plus y square. So according to this nice formula, we just expand the above cubic equation as in this form. So we have, this is a minus 1 times of a square plus a times of 1 plus 1 square, and this whole equation is equals to 0. And in the next step we need more simplifications here. So first we rewrite this equation as, because here we have little bit more simplification. This is a square plus a times 1 becomes a plus 1 square becomes 1, and this whole equation is equals to 0. And now we break this equation into the two cases. The first case is we write a minus 1 is equals to 0, and the second case is we write a square plus a plus 1 is equals to 0. From here we move minus 1 to the right hand side, and we get the value of a is equals to plus 1. So this is the first real root of the given equation. And now in order to find the other roots we need to solve this quadratic equation. So in order to solve this quadratic equation we need to apply here quadratic formula. So for this we need to write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 1, and c is also equals to 1. So we state the quadratic formula as a equals to minus b plus minus square root of b square minus 4 times of ac, and it is divided by 2 times of a. So here we substitute all the values of a, b, and c, and we get here our final answer. So we have a is equals to minus b. The value of b is 1, so it will becomes minus 1 plus minus square root of b square. B is 1 and becomes 1 square, minus 4 times of a is 1, and c is 1, and it is divided by 2 times of a, and here our a is also equals to 1. Further, in the next step we have minus 1 plus minus square root of 1 square becomes 1 minus 4 times of 1 equals to 4, and this is divided by 2 times of 1 is equals to 2. So further in the next step we need more simplifications, and we have minus 1 plus minus square root of 1 minus 4 becomes minus 3, and it is divided by 2. And now here we need to focus on square root term, and we break the square root on both of these two terms as square root of 3 into square root of minus 1, and it is divided by 2. So in the next step we need more simplifications here, and you see that we have minus 1 plus minus square root of 3 into this is square root of minus 1 becomes iota, and it is divided by 2. So finally we have there are three roots of the given equation, in which the first root is real root, it is a1 is equals to 1, and the other two roots are complex roots. So the second root a2 is equals to minus 1 plus minus square root of 3 minus 1 plus square root of 3 iota divided by 2, and the third root is a3 is equals to minus 1 minus square root of 3 iota, and it is divided by 2. So finally we have these are the three roots of the given equation, in which two roots are complex and one root is real, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more interesting and exciting videos. Thank you so much, and bye bye.